Hi, I'm Pieter Kok from the University of Sheffield, and I've spent the last 25 years thinking about light. Our current understanding of light throws up a paradox that we still don't understand.
The light you experience every day is made up of photons that can travel the universe unimpeded. Photons from galaxies billions of light years away reach our telescopes without aging, and when they are detected, they disappear into pure energy.
Special relativity tells us that when you travel close to the speed of light, time slows down and distances contract. But what happens when you travel at the speed of light? Well, for a photon, time slows to a halt. To us, it may spend billions of years traveling across the universe, but to the photon there is no time between the emission and absorption. The photon is born and dies at the same time. Traveling between distant galaxies and neighboring atoms is the same thing. Weird or what? Photons are created when electrons jump between energy levels. This can happen in many different ways, for example in LEDs, lasers, or the chemical reaction in this glow stick. But what is a photon? It's not a wave, it's not a particle, it depends. And here comes the paradox. When we're not looking, quantum mechanics tells us that a photon doesn't exist. So was there ever a moment when we could say that the photon really existed? We can use photons to build quantum computers. Here in Sheffield, we build little light sources that emit single photons, called quantum dots. We can place these quantum dots on the surface of a chip and let them emit photons into tiny fiber optic cables that are also on the chip. We use lasers to excite the electrons in the quantum dots to emit a single photon. We can measure these photons using highly sensitive photodetectors. So how does a quantum computer work?
When traveling through the fibers on the chip, the photons have two possibilities: staying in the fiber or jumping to a neighboring fiber. And because the photon is a quantum particle, it does both at the same time. When we have many photons going through the fiber chip, we can control how they interfere with each other and become entangled.
And this allows us to build the logic elements that we need in a quantum computer. We can also use photons in a different way. We can harvest photon energy using solar panels to power our world. Here we develop semiconductors called perovskites. These can be printed on surfaces to make new solar cells that are efficient and cheap to produce. 25 years ago, this video would have been brought to you by electrons moving through copper wires. Now, information is sent across the internet via light pulses streaming into fiber optic cables. What will the next 25 years bring? Who knows, but it will certainly involve photons. So the next time you turn off the light, spare a thought for the humble photon.